Welcome to our video presentation. We are Atlas Civil Engineering, a design team commissioned by the City of La Mesa to develop a pedestrian bridge connecting Parkway Drive and the 70th Street trolley station.
Hi, I'm Rose. I'm a fifth-year civil engineering major, and I was the lead CAD and structural personnel for this project.
My name is Valeria Contreras, and I'm a graduating senior, and I was in charge of geotechnical analysis and foundation design.
My name is John Taylor. I'm one of 3 structural engineers on the project.
Hi, my name is Hannah Rebello. I'm a civil engineering major. I'm in my senior year, and I did the traffic impact analysis and the traffic station plans for the 70th Street pedestrian bridge.
My name is Christopherson Garcia, and I worked on the hydrology construction portion for this project.
And I'm Jennifer Womeyer. I was the project manager for our team, as well as both the stormwater and environmental engineer for this project. This project is located in the City of La Mesa, a community with 60,000 residents located in the heart of San Diego County. It connects the 70th Street trolley station, located on Alvarado Road, with Parkway Drive across to Interstate 8. This community along Parkway Drive has the potential to use transit, but due to unsafe and inconvenient road conditions along 70th Street, they avoid the use of this station.
The City of La Mesa is moving forward with becoming more sustainable and pedestrian friendly, which has necessitated the building of a pedestrian bridge that will serve as a gateway to the city. Building the bridge presented 2 major qualifications, which was fitting in with the city's climate action plan and presenting pedestrians with a safer and more convenient path to travel than what's currently available. There are several existing conditions we had to take into account when designing the bridge, including the freeway, the trolley station, utilities above and below ground, and the public and private land we had to be either considering or acquiring for the bridge. There are 3 major utility considerations we had to make. First one being telephone wires, which we'll have to bury. The second one being the trolley itself, which you have to build it far enough above and far enough away to clear the tracks. The last one is the gas line that runs under the street. That must be avoided at all costs.
We designed a cable-stay bridge in order to reduce the amount of load and also in consideration of construction over the I-8 and maintaining the requirement as a gateway bridge for the City of La Mesa. The deck layout is based on the anchors layout as well as ADA guardrail requirements, all while accommodating for multimodal transportation. Having tested different models such as the box girder, slab, we finalized on a custom deck able to support our cable anchorage requirement. The deck was analyzed as a beam in a Caltrans falsework analysis program shown here. The cables for the bridge was designed under harp-style requirements with the towers accommodating a higher volume than the deck in question. We also incorporated 2 different decks in order to reduce load being supported by our foundation, which is also shown here. The design consideration for the foundation of the bridge was based on the total load of the deck and the tension in each of the cables. At Sister Tower 1, for example, the total load to be supported was 1,413 kibs, which is about 9,423 feet cubed. Thus, we designed our foundation to be of a volume of 9,473 feet cubed and followed the same principle for the second set of towers.
The ends of the bridge land on 2 different kinds of property. One side is public, the other side is private. On the public side, we built an elevator due to space constraints and vertical clearance. And on the other side, we built a ramp because an elevator would be seen as an eyesore while a ramp is more aesthetically pleasing.
Our soil study determined multiple soil layers in our project area. The soils encountered in test boring 1 were alluvium, which is classified as a fine silty sand. The second soil type was stadium conglomerate. Boring test 2 on Parkway Drive consisted of alluvium, stadium conglomerate, and colluvium, which is classified as a clay sealed, fine sand, and fine gravel. The stadium conglomerate layer is suitable for foundation design since it has a high bearing capacity. Project location is not on an active fault zone, therefore critical seismic activity will not affect our structural design. Liquefaction could be a potential factor since alluvium and colluvium are categorized as loose sandy soils. Erosion could not be a problem since horizontal construction is mainly ground level. Based on our soil analysis, we recommend casting place concrete piles that reach the stadium conglomerate layer and account for the high load of the superstructure. Pile design is based on the beta method for determination of ultimate bearing capacity for drained soils. Our analysis resulted in the selection of 4 piles of 1 meter in diameter and 30 meters in depth, with a factor of safety of 2.6. Foundation further up on Parkway Drive uses shallow foundation design. We calculated 6 meters in depth and 6 meters in width with a factor of safety equal to 2.
The need for a pedestrian bridge to address the unsafe existing pedestrian conditions near the 70th Street trolley station was central to the initial site layout and alignment of our bridge design. The lack of safe pedestrian facilities in the area to convey walkers and bikers to the MTS trolley station, paired with the City of La Mesa's initiative to increase active transportation, drove our design and indicated the need for a pedestrian bridge connecting Parkway Drive to Alvarado Road. The impact analysis of the structure was based on the increased average daily traffic volumes in the area. For example, Lake Murray Boulevard, Alvarado Road, and 70th Street, as estimated by the 2050 projected data from the Sandag Transportation Information Center, showed dramatic decrease in LOS as traffic volumes increased in the future. The impact of the bridge has potential to reduce traffic volumes as it would encourage drivers to use public transit. Other implications for design were the pedestrians it would impact in the City of La Mesa. Based on the City of La Mesa zoning and the Sandag not-so-brief guide of vehicular traffic generation rates, the total number of vehicular trips were calculated for the study site just north of Parkway Drive. This number, when multiplied by the 5.5% of the City of La Mesa that would walk, bike, or use public transit from the 2010 census data provided by Sandag, showed a reduction in over 1,000 trips, as this percentage has the potential to use the bridge and public transit to transport themselves. Further, based on the La Mesa Urban Trails Mobility Action Plan, 84% of survey participants in the City of La Mesa strongly agreed that trolley stations or bus stops should be within 10 to 15-minute walks or bike rides, which shows the public interest in the use of public transit. From design, the maximum reduction in travel time was 12 minutes with a distance reduction of 0.5 miles. This reduction in travel time, as well as the proposed pedestrian facilities, fits into the climate action plan put out by the City of La Mesa and provides a safe route for residents to use public transit and to actually transport themselves.
Based on these transportation findings, an estimated 1,025 cars will be taken off the road each year as commuter vehicles. Because fewer cars would be on the road, the city will see a large decrease in GHG, and about 5,800 metric tons of carbon dioxide will be removed from the air each year, contributing to 35% of the total La Mesa Climate Action Plan goal target for 2020.
The methods taken for the hydrologic analysis of this project follow the County of San Diego's hydrology manual. This analysis followed the rational method, where the equation Q equals CIA was utilized to calculate discharges. Discharges for our 100-year, 10-year, and 2-year storms for the existing and proposed landscapes were found. The findings showed that the project would not be affected by the current hydrologic landscape in the area. This is due to the stormwater runoff that is shedding away from the proposed alignment on the Parkway and Alvarado side of the bridge.
Our stormwater analysis found it necessary to treat all water that fell into our project site. By consulting the San Diego County BMP worksheet, we found that the introduction of bioretention basins on both the north and south sides of the bridge were ideal. Creating a ponding depth of 3 inches and a soil matrix depth of 2 feet provided more than adequate treatment for the stormwater predictions of our hydrologic findings while allowing room for plant growth. We devised the bridge to sheet drain at gradual slopes ranging from 1% to 8.33% to eliminate pooling while remaining ADA compliant.
The construction methodology for the project consisted of breaking the project into several different phases, which begins with construction of the elevator tower and ramp as phase 1 and 2, with the structures being casted in place. For phase 3 and 4, construction for the base tower begins, starting with the tower within the I-8 median for phase 3. The tower and the piles will be precasted and spliced. Then, we move on to Phase 4, the tower being constructed on the dirt area adjacent to the eastbound shoulder of the I-8. Phase 5 will consist of the deck construction, where the precasted splices will be placed and the strands tensioned on site. After the completion of the deck, construction for the bioswales, lights, elevators, and other site finishes can be begun, leading to the end of construction. The duration for this project was determined to be 11 months, shown in the linear schedule. Also, the engineer estimate totaled the project at approximately $9 million.
Based on our findings and results, we conclude that if built to specification, this bridge will have a positive impact on the community and the environment of the City of La Mesa. Once built, convenient and safe trolley access will promote MTS ridership by allowing citizens a feasible alternative to car commuting. This will improve both GHG emissions and traffic conditions in the area. The 70th Street Pedestrian Bridge is a perfect fit for the La Mesa community and would stand to represent the ambitions of the people of La Mesa.